All right. One of the things we talked about the other day was we talked about that you should know some basic shapes of some graphs, okay? So when you have something like y equals a negative 1/2, what does y equals a number look like? Horizontal line. All right, if it's a positive number, it's going to be a horizontal line above that x-axis. If it's a negative number, it's going to be a horizontal line below it. What does y equal x look like? All right, y equals x when it's just like a linear. All right, that's going to be that diagonal line that splits quadrants 1 and 3 1/2. When does it look like a parabola? When something's what? Squared. When one of your variables is squared. Now, if both are squared, that's a different graph. Everybody with me? Okay. Then you've got y equals like something cubed. So what's the basic shape of something when you got y equals like x cubed? Like an S curve. Okay. And then what does absolute value look like? It's got that v. And then the square root functions looks like half of a parabola. Okay. Now knowing those basic shapes ends up being pretty helpful sometimes. All right. Now look at this one. Do you notice this is what was it, number 5, Catherine? All right, this is number 5 on your homework. This basic shape, do you see that you've got a variable eventually squared if you multiply that out? Okay, so I know it's going to be a parabola. Is everybody with me? Now, this is the part that to me is a little counterintuitive. Now, what I told you kind of on the video is I would make a table. I mean, I would make a t-table, x and y, and get myself some points, all right? But what I want you to notice is if you were graphing y equals x squared, what's that graph going to look like? Parabola, right? Where's the low point? Where's the vertex at? 0, 0. Everybody with me? So you'd have like 1, 1, you'd have like negative 1, 1, you'd have like 2, 4, if you had made a t-table on this. But you know kind of the basic shape. So that would be y equals x squared. Now, to me, this is the one that's a little counterintuitive. What happens if this minus 4 is inside the parenthesis with the x? Does it move it 4 places to the right, or does it move it 4 places to the left? To the right, which is kind of counterintuitive. Is everybody with me? In other words, here's what I'm expecting when I plug this number in. If I take this number and move it 1, 2, 3, 4 over here, wouldn't that put it about right there? Now, what's the x value right there? 4. Isn't that the point 4, 0? And sure enough, if you plug a 4, in a minute, if we plug a 4 in, look what's going to happen. I'm going to have 4 minus 4 is going to give me a what right there? A 0 what? Now, we got to figure, we're going to do something with that plus 2 in a minute. Is everybody with me? But I'm expecting in a minute for this point to shift again. 1, 2, 3, what? 4 units. I'm expecting this one to shift 1, 2, 3, 4 units. Now, what's this plus 2 going to do though? After I shift it to the right, what's it going to do with all these points? It's going to shift it what? Up how many? 2. So I'm expecting this point to go up 1, 2. Is everybody with me? And I'm expecting that point to go up 1, 2. And that point to go up 1, what? 2. And sure enough, look what happens if I put in 4. If I put in 4, 4 minus 4 is 0, and 0 squared is 0. What's 0 plus 2? 2. And sure enough, that point right there is 4 what? 2. If I put in this point, which is 5, what's 5 minus 4? 1. All right, what's 1 squared? Still what? 1. And what's 1 plus 2? 3. And sure enough, that's the point 5, 3 right there. If I plug in 1, 2, 3, 3 minus 4 is what kind of 1? Negative. But what happens when you square a negative 1? What do you get? Positive 1. And when you add 1 to 2, I get another what? 3. So sure enough, what happened, now you can get more points. Is everybody with me? We're just kind of doing a rough sketch right now. But it took this basic y equals x squared parabola and it shifted it to the right 4, then it shifted it what? up to. And that sort of helps me also know which points to grab for over here. Is everybody with me? Instead of just randomly grabbing points. Now we're going to talk a little bit more, probably by the time we end up doing it, Friday maybe. Friday or Monday, we're going to talk more about quadratic functions, okay? We're going to kind of take a little deviation today about something. But that's all they're trying to get you to do is when you've got a number added here at the end, if it's positive, it takes your basic common graph and shifts it up. If you're adding a negative or subtracting a positive, those are the same things. It shifts it what? Down. Now that's intuitive to me. Up, down. Darren, do you have a question?
Yes, ma'am. So on a test for the minimum, how many points do you require, like for your graph?
And that's a good question, Darren. How many points do I require for a minimum? I don't really have a minimum.
Okay.
And what I mean by that is for a parabola, personally, I probably need at least 5 or 6 points before I felt comfortable kind of doing it. Now, what we're going to do, like I said, Friday or Monday, is we're going to go back to quadratics and talk about which you can have different points, except everybody on a parabola's got to have 1 point that's the same. What's the 1 point everybody's going to need on a parabola? That vertex. Everybody with me? In other words, everybody would need to know where that low or that high was. And then Darren might need 4 more points. Brock might need 6 more points. I might need 10 more points before I felt comfortable drawing it. So everybody won't have the same t-table except like on a parabola at 1 point. The same thing on that S-curve. Everybody needs kind of where it shifts from like this to like that. It's called an inflection point. Everybody's going to need that one. But then I might need 22. You know, Catherine might only need 5. It just varies with how common they are for you. So I'm used to doing this a lot, so I might need a fewer points. But when I used to do it a lot, my t-tables were pretty long. It's kind of a matter of when you feel comfortable drawing it. Okay? Now, to me, this one was a little stranger. When it was minus, I expected it to shift left, but it shifted what? Right. But here's the reason you kind of, if you think about it, after you think about it a minute, you go, oh yeah. You know, before, for me to get 0, I've only got to put a 0 in there. But for me to get a 0 out of this, I've got to stick a 4 in there. Is everybody with me? So I've got to go more to get the same thing I got over here. So when it's minus a number in the parentheses, it shifts it right. When it's plus a number that's positive, it's going to shift it what? And again, you can draw the graph with just t-tables. I just think when you know kind of that basic shape and the shifts, you can kind of double check yourself one way or the other. I tend to do better thinking about the shifts first before I do the t-table, because then I know kind of which numbers to grab on the t-table rather than me just randomly grabbing some numbers. Okay? All right. So does everybody feel okay about doing some basic graphing? Are we good with that? All right. Now, here's kind of what we're going to do. This is college algebra with applications. All right. So one of the things I do is try to do some applications that I think probably end up being maybe a little more helpful. Maybe. We'll see. We'll see. So before we go on with quadratic functions, I want to kind of shift back. I felt the need to make you feel a little bit better about algebraic skills. We're going to shift back to a certain kind of word problem on interest. Okay? We're going to talk about simple interest today and compound interest. Okay? Then we're going to shift from that to what I call, they're called amortization schedules and things, but basically it's like payments. All right? Because regardless of your major, I do suspect at some point in your life you're going to buy a car or a house. I don't want you ripped off. All right? So we're going to kind of do a little deviation there. The reason we're not going to call them functions though is we're not going to be putting one thing in. We're going to be putting several things in. Now think about it. If I go borrow money or I go put money in a savings account, all right? If I go borrow $1,000, do I just have to pay back $1,000? No. All right, what's that extra money I got to pay back called? Interest. So how much interest depends on several things. What's one thing you think interest would depend on?
How long?
How long you kept their money. You keep their money longer, you're going to pay them more. All right, so that's true. That's one thing that's going to be a big difference, how long you keep the money. What else is going to make a difference?
How
How much they gave you. Again, if they give you $500, but they give you $5,000, again, the more they do for you, the more you give to them. Okay? So how much you borrow is going to be a big deal. We said how long you keep it. What's the other thing somebody said? The rate. The interest rate. Now, what happens is when you start borrowing money or having a savings account, you're going to have to shop around some for interest. All right. Now, it also depends on where you live and what time you live and what the market's doing. Now, we're going to start with simple interest. All right. So here's what you told me. You told me it mattered the money, the initial, let's say the initial amount. What's initial mean? Beginning or end? Beginning. So I agree. The initial amount of money matters. You told me like the time, like how long you keep it mattered. And you told me that the rate mattered. And I agree. Now, when you look in most books, here's the formula they'll have. I'm going to do this formula and then I'm going to show you kind of another formula. All right? I equals P times R times T. Okay? This P is your initial amount. It stands for principal. All right? Not the guy from school. All right? But, you know, that's the initial amount of money. All right? This R stands for your interest rate. Okay? And this T does stand for time. How long are we talking about? And then this interest is the extra money. Now, if you're borrowing the money, that's the extra money that you pay them. If you have a savings account, that's the extra money that they pay what? You. Now, let's just use a little common sense. Do you think the extra amount that you pay them is going to be the same as the extra amount they pay you? Mm-hmm. Oh, it's not remotely the same. It's very sad, but it's not. Okay? So, here's what happens. So, what if I gave you something like this? Now, we have to have things alike, so I want you to kind of write yourself a note. The rate and the time must, and I'm going to put an air, kind of in air quotes, match. The rate and the time must match. Now, what do I mean by that? I mean that they both got to be in like years or months or days. Everybody with me? So that because they're going to tell you the interest rate is like 10% per year or 4% per month. All right? The time might be 6 months that you kept the money or 16 years. So they've got to match. So if they don't match, you've got to change one of them. Okay? So let me kind of give you an example. So suppose I told you that you borrowed $500 for 9 months. Okay? You're going to borrow $500 for 9 months, and we're going to say at a simple interest rate of 8%. I'm going to ask you several questions. All right, I'm going to ask you how much interest you owe. And I'm going to ask you what amount you must pay back. So what amount do you pay back? Okay. So you've got $500 a month. Maybe you borrowed $500 for 9 months. Okay. Maybe you had to make some repairs on your car. All right. Maybe your roof leaked. Okay. So there's some short-term little loans sometimes that you've got to run, kind of get. All right, Brock?
So on this, you said the rate and the time have to match?
That's right. So what's bothering you?
It doesn't say.
It doesn't say. Now, anytime it doesn't say, it's per year. Okay? So because it says the interest rate's 8% and it doesn't say per anything, what do I have to assume it means? Per what?
Per year.
Per year. If it's per month or per quarter, they've got to say per month or per quarter. Okay? That's a very good question. So I'm going to come over here and I'm going to fill it in. All right? So I've got my little formula. I know what my P, my R, and my T are. I know what they stand for in the formula. All right? So what's my initial amount of money? What's my principal? How much money? 500. All right, how long am I keeping the money for? 9 months. All right, now what's my rate? It just said 8%, didn't it? All right, but as y'all pointed out, if it doesn't say, it's got to be per what? Per year. All right, and I'm very proud of you because the first thing you did was you noticed you've already got a problem. They don't match. So if they don't match, you got to change one of them. And it doesn't matter which one you change. I can either change this to years, or I can change this to months. And we're going to do it both ways. Which one would you change? I'm curious.
12 months.
You would change this to this? Okay. If I'm going to change this, if it's 8% per year, how would I figure out the interest rate per month? What would I have to do?
0.8 times 12.
Well, let's think about it. If it takes a whole year for me to have to pay 8%, would it take more or less for 1 month? It would take what? Less. So I wouldn't multiply by the 12. What would I have to do? Divide by the 12. Now, I'm not going to divide 8 by 12. What am I going to divide? What's 8% as a decimal? Point what? All right, so you've got a calculator, so you take 0.08 for me, and I want you to divide that by 12. Zero 0.08 divided by 12. In other words, we're gonna need. I think a decimal is going to be probably better for us.
0.00.
And then what happens?
It just keeps going.
It just keeps going. Now, here's what's going to happen. The further out you go, the more accurate your answers. Everybody with me? And I've got a calculator. So I'm going to go 0.00. Then it just keeps repeating sixes until finally it terminates it at the ends. Everybody with me? I would go out several, I'd probably do, I don't know, 3 or at least 4 or 5 spaces. So 0.00 maybe 6, 6, 6. We're not going to do the last one though. We're going to make it a what? 7. Just don't chop it off real soon. Because as soon as I chop it off, does everybody understand we'll get a little bit of error?
I don't know what I didn't get a 0.00. I got like 6.6.
Okay. Thanks, Caroline. So you got 6.6. Now look all the way out to the end of your calculator. Does it say E? I have to look at it. A lot of your calculators will shift into scientific notation.
Oh, yes, mine says.
Does that make sense? In other words, if you get something like this, what does it really mean? So it's probably what, a 3?
The decimals.
Right. In other words, that means this is giving you scientific notation times 10 to the -3. Is everybody with me? So it's telling you to take that decimal and shift it which way if it's negative, left or right? Left. How many spaces? 3. Then wouldn't you end up getting about the same thing I've got? That's a very good point. I'm glad you brought that up. Okay. So does everybody see where I got this? And that is per what? Per month. Now, do they match? Now they match. So I'm going to go over here and substitute in. All right. What's my initial amount? We agreed it was how much money? 500. what's our rate? We're not gonna put 0.8, we're gonna put 0.006667, aren't we? And then what's our time? That was per month, so I need months, so what's that gonna be? 9. Is everybody with me? All right, so you go get that and see what you get. Now, isn't this money? So if it's money, what do we have to round to? The nearest what? Penny, right? The nearest cent. So how much money are y'all gonna get to the nearest penny? Just $30 and what? Zero. Everybody with me? I got 30.0015. Is that what y'all got? So if I do 30.0015, if I look at this number's what matters. If that number's 5 or bigger, that one goes up, doesn't it? And if it's 4 or smaller, it stays the same, so it's gonna stay what? The same. So it's just gonna be how much money? $30. So does everybody understand? That would be my answer over here to A. How much interest do you owe? I owe how much? $30. Okay? Now, B says, what amount do you pay back? Do you just pay them back $30? No, what's my total amount gonna be? 530. Now, what we're gonna use for future amount is an A. So we're gonna let A stand for the future amount. So how do I get the future amount? What would I have to do? I mean, you did it right in your head automatically. What did you do to get that 530? You added what you started with, right? We call that the principal. And then what did you add to that? The interest. So you said, okay, I borrowed $500. They're going to charge me an extra $30. So how much money do I owe at the end? 500 what? $30. Well, I can write. So that's my future amount. So does that make sense to everybody? We good? Now let's go back and rework it for a second. Remember how I told you it didn't matter which one you changed. All right. So let's go back and do this. And see if we get the same answer. If this is in years, what I could do is turn that into what? Years. Now, is 9 months more or less than a year? Less. So am I going to be multiplying by 12? I'm going to be doing the same thing. What am I going to be doing? Dividing by 12. So I could have taken this 9 and divided by 12. All right, do that on your calculator for me. And tell me what you get.
0.75.
0.75. And that's per, now that is what? That's 0.75 years. So now they match, but instead of matching in months, they match in years. So my principal is 500. My rate is 0.08. Is everybody okay with that? That's that 8% is the decimal. All right. And what's my time? Point what? All right. So you go do that on your calculator, see what you get. So I've got 500 times 800 times 7,500. And again, what do I get? I get what?
30.
I get 30. Just like I got before. And so again, my answer to A would be 30. My answer to B would still be 500 what? 30. Everybody okay?
Why does the first way give you the decimal after 30?
Okay, that's a very good question. Did you hear what Brock asked? He wanted to know why did the minute ago when we did it the other way, I got 30.0015 and it kept going. Why are the answers not identical? That's right. On the first way, we had to round because our 0.08 divided by 12 didn't terminate. Is everybody with me? And as soon as I round, I get a little bit of error. Did I have to round on this one? No, that 9 divided by 12 came out to be exactly point what? 75. But as long as I did the rounding way out, is everybody with me? Didn't they come out to be the same? Now, if you had rounded to 0.007, remember how I told you to go 4 or 5 places instead of like 2 or 3? They'd have been off just a little bit more. So that's why if they don't come out pretty, if they don't terminate, you're going to need to round pretty far out. Now, I'm going to be honest with you, all right? I would love to tell you that a lot of financial institutions round mathematically, but sometimes they don't. Now, we are going to round mathematically in here, okay? But here's what I mean. What if the interest came out to be this? All right, if it came out to be that, we would all round to 1 cent or 2 cents. We'd all round to what?
2 cents.
2 cents. Everybody okay? But there are some financial institutions that will do this. That's a 1. So should this stay a 1 or go up to a 2 mathematically? It should what? Stay a 1. A lot of financial institutions, they'll round it to 2. Because, and here's their reasoning. Somebody's going to lose part of a penny. You with me? Either they lose 1/10 of a penny or you lose 9/10 of a penny. Now, if you lose a part of a penny, have you really lost very much? No. But if they lose a part of a penny on millions of customers, now their part of a penny becomes what? A lot. So sometimes on a financial institution, depending on where the money's going, the same thing though if it's going to your savings account, if somebody's going to lose, guess who's going to lose? But they're a business. Is everybody with me? And there is some rationale there. Me losing part of a penny is not a big deal, but them losing part of a penny a million times, now they're losing thousands of dollars. And they're a business and they can't be losing thousands of dollars. But we in here are going to round off mathematically. If this number, if the next number is 5 or bigger, that one goes up. If it's 4 or smaller, it's going to stay what? The same. Now, I'm going to show you a different formula. And you can do it either way you want to. All right? It's just I think the second formula is going to make a little more sense if I write this formula a little differently. All right. You automatically told me that A would be P plus I. Right? Now, let me show you something. How do you calculate the interest? Don't you do the principal times the rate times the time? What could I factor out of both of those if I wanted to? A P. If I factored a P out, what do you multiply P by to get P? Just a 1. And then what do you multiply PRT by? If you've already got the P, you just need the what? R and the T. This is the way the formula looks in your book. And I'm going to rework the problem using this formula. Okay? Now, do you have to use this formula? What's the answer? No, you can go back and use what? This formula. And then realize, how do you get the future amount? You take your initial amount and then add it to your what? Your interest. But I'm going to use that formula and rework this problem and answer both of those questions. Okay? So look what would happen. So that you can do it either way you prefer. For a lot of people, that looks a little more intimidating. Okay? But it's really not. What's P still? The what? The principal, right? And my R is still my rate. And my T is still my time. And my A is still my future what? Amount. What's going to happen though, instead of me answering A first and then answering B, this form is going to answer B and then I'm going to have to figure out what? A. So just like before, since we got this on the board, let's just go with this. Okay? What's my initial amount? It was what? 500. I've got 1 plus. Now this one, I need my rate and my time to match, and I've got them both in years. Okay, so what was my rate? It was 0.0 what? 8. And that was per year, and my time was point what? 75. Now, don't I have nested groupings like parentheses inside of other parentheses, so to speak, inside of a bracket? Don't you work from the inside out? All right, well, if I look inside this bracket, do I add first or multiply first? I multiply first, right? You got your calculator. I'll walk over here and get mine and see if we get the same thing. So I've got 500, 1 plus. What happens when I take 800s and I multiply by 7500s? Which y'all get 0.0 what? 6, good. All right, then I've still got that bracket to worry about. And 1 plus 600 is 1 and what? 1.06. And now say that times 500. And what do you get? 530. And that's my future amount. So how would you know the answer to A now? Well, what was your initial amount? 500. What was the future amount that you ended up paying back? 5 what? 30. So how much interest must there have been? $30. It'd be the difference between the two now. Okay? So as far as working on a test, I don't care which way you do it. I don't care if you use the first formula and then add that amount to the principal. I don't care if you use this formula. Is everybody with me? Now, we're going to talk about compound interest because really the world doesn't work on simple interest money. But you have to understand simple to understand compound. Now, let me put this up here while I'm thinking about it. All right. On simple interest, the interest is calculated once. So on simple interest, that simple interest is calculated just one time on the whole time. Compound interest, the interest is calculated multiple times. Now, all right. We're going to borrow $1,000. All right. At 10% compounded biannually for 1 year. Now, I'm going to work it a different way, and then I'm going to show you a shorter way. Okay? Now, when it says the interest rate's compounded biannually, what's the prefix bi mean? 2. That means twice a year. So after 6 months, they're gonna do the interest. They're gonna do the interest, and then go ahead and stick it in there, and then you're gonna pay interest on that interest. What did you cut, Bob?
So they do it at 10% at the middle of the year, 5%.
Well, that's what I'm gonna say. We're gonna have to make a match again. So you're right. If it's 10% per year, and I'm doing it biannually twice a year, that means I'm doing it every what? 6 months. That means at the 6 month mark, it's not going to be 10%. It's going to be what? 5%. We're going to do it. Then they're going to go ahead and stick that in there. Is everybody with me? Now I got to pay interest on that. Is everybody with me? Now, what do you think quarterly will mean in a minute? 4 times a year. What's monthly going to mean? 12 times a year. What's daily mean? Guess what your credit card does? Daily. Your interest is compounded daily on your Visa. So every day that goes by, they charge you interest and stick it in that account, and the next day, you don't just get it based on what you charge. Your interest is charged on that interest plus, what you borrowed plus that interest from yesterday. And then the next day, it charges you on what you borrowed, the interest from Monday and Tuesday. You see how people get in credit card trouble really quickly? Because it's compounded daily. Okay? So I'm going to do this kind of a longer way, then we're going to do it a shorter way. All right, now I'm going to, just for sake of, I think it'll make a little more sense to you, I'm going to go back to this simple I equals PRT for a second. Now, what's my principal amount in this problem?
1,000.
1,000. All right, what's my rate? 10% doesn't say, so it must be what? Per year. And my time, though, is what?
1 minute.
1 year. Now, here's what we have to do with compound interest. All right, it's got to match, and I'm going to put periods. Now, this goes back to Brock's question. All right. They're both per year, but I need them both what? By what? Annually. So biannually means every what? Half a year or 6 months. Is everybody with me? So I'm going to do it the first half and then do it the second half and see where we end up. Okay? So do we understand if it's 10% per year, then it's going to be what per half a year? 5%. So it'd be 0.05 per period. I'm going to put period, I'm going to put in parentheses half a year. Now, my time is going to end up being, how many times am I going to have to do this? If I'm doing it every half of a year and I'm doing it 1 year, I do it how many times? Twice. What if I did this for 10 years though? How many times would I have to do it? 20. Is everybody with me? Because I'd have to do it every half year for 20 years. Now, my interest rate is, and I'm going to put in parentheses twice. Now, just look up here. I wouldn't copy anything down yet because you're not really going to work it this way in a second. I just want you to look to see kind of where it comes from. My principal's $1,000, right? In the 6 months, what's my interest rate going to be? 0.0, what at the end of that? 0.05, and I'm only doing it once. Is everybody with me? I'm doing it for 1 period. All right, go find me your interest on this. $50? Now, so what's my future amount right now then? 1,050. Does everybody see where we got the 1,050? We took our 1,000 and what? Added our 50. So now we've got 1,050. Now, the principal now isn't 1,000 on the second 6 months. What's my principal? The end of this is the beginning of my next 6 months, isn't it? So now they're going to charge me interest on the next 6 months, not on 1,000, but on 1,000 what? 50. And again, it's going to be for what? 5% for another period. Is everybody with me? So go find me the interest now. Did you get $52.50? Everybody with me? So what's my future amount going to be now? Isn't it going to be my principal plus my interest? But what was my principal? My beginning amount this time was 1,000 what? 50. Plus my 52 what? 0.5. So how much am I going to owe at the end of the year? 1,100 what? $2.50. Now, do you understand if I did it another year, this will be, do you understand that the end amount here becomes the beginning amount on the next one? And the end amount here becomes the what? Beginning amount on the next one. Now, do you see how if we were doing this for 20 years though, you really wouldn't want to work it this way. You'd be like doing it forever, okay? That's why this is going to be your formula for compound interest. Okay. It does it all at once for you. Now that's why I said, do you remember I wrote this one down a second ago? That was the one we wrote for simple interest, remember? The other formula the second time. And I said you could work it either way, but this formula then looks a little more like that formula, which may be better for some of you and worse for some of you. Does that make sense? If you think you're going to get the two confused, then use that I equals PRT for simple. But this is your formula for compound interest. Okay? Now, what's A stand for? Remind me, what does A stand for? That's my future amount. That's the amount at the end. What's my P stand for? Still what? Principal. Now, is principal the beginning or the end amount? It's the beginning amount, so I'm going to put initial amount. What's I stand for? Like I don't see an R in this one, is it? So instead of them putting R for interest rate, they put I for interest rate. But I'm going to put it's per period. And I didn't put that before. I think that's why they changed the letter on you a little bit. All right. Do you see that it doesn't have a T, it has an N? And that N is your number of periods. So instead of putting R and T and just saying they have to match, they have I and N. And it's per period. Period and period. So if it's compounded semi-annually, they both got to be in terms of semi-annual. If it's compounded quarterly, everything's got to be in terms of quarters. If it's compounded monthly, your period is a month. So everything's got to be in terms of months. So we're going to go back and work this same problem with this formula. It's going to be a lot quicker. Okay? Now, if I asked you how much do you owe at the end of the year, and I ask you, so how much interest did you pay? Now notice, I kind of switched the order of the questions that I did on simple interest. Because this one, you're going to need to figure out how much you owe at the end and then backtrack to see how much interest you earn. Now, help me with this problem. What's my P? My P is still what? $1,000. Now, compounded biannually, sometimes I'll say semi-annually. That's still going to mean how many times? Twice. I've got to have everything in terms of biannual or semi-annual. All right. So my period is half a year, so it's 5% per period. How many semi-annuals do I have? Do you see that my T is going to be 2 half-year periods? Because I'm only doing it for a year. What if I were doing it for 3 years? What would my N be? How many times am I doing the interest if I'm doing it every 6 months for 3 years? What would my N equal? 6. Does that make sense? If I were doing it biannually for 10 years, like we said a minute ago, my N wouldn't be 2, it would be 20. Does that make sense to everybody? All right, so let's go over here and try this formula. What was my P? It was what? 1,000, good. I've got 1 plus, what's my interest rate per half year, per biannual? It's how much? 0.0 what? 5. And how many times are they doing the interest over this whole loan? They're doing it twice a year for 1 year. It's only how many periods? 2. All right. So I've got $1,000. I've got 1 plus. Now again, am I going to add first or multiply first? What am I going to do? I'm going to multiply. All right, so I'm going to get, what's 0.05 times 2 going to get me? You got the calculator. What do I get? Point what?
1.
0.1. So I've got $1,000 times 1.1, don't I? So how much money is that? $1,000 what? $100. Which is almost exactly what we got a minute ago with a little bit of rounding. Is everybody with me? So if I've got to pay, is that right?
I thought you were supposed, that 2 was supposed to be an exponent.
Oh, it is. I'm so sorry. I'm not paying attention. Thank you, Brock. All right. See what Brock said? So I've got 0.05, and that end's supposed to be up here. Is everybody with me? So I've got to make sure I put it in the right place. Thank you, Brock. So I've got 1,000. So I've got 1.05 to the 2. I've got to do parentheses first, right? Now, do I multiply next or do exponents next? Which one do I do? Which order of operations say you do first? Exponents or multiply? Exponents. All right, so let's do that one. So I've got 1,000. Did you get 1.1025? All right, so when we say that number times 1,000, did you get $1,102.50? Everybody okay? So that's how much money we pay back. How much interest do we owe then?
$102.
$102 and what? 50 cents because we borrowed 1,000. Now, we're not gonna do this, but I want you to write it down and set it up so I can make sure you're clear about this. So this way I don't have to do it 14 times by hand. The formula does it for me. What if you borrowed $2,500 at 8% compounded monthly for 5 years? Okay, so you're borrowing $2,500 at 8% compounded monthly for 5 years. Okay? To use that formula, I'm going to need an A, a P, an I, and an N. Do we agree? Okay. What's my P? What's my initial amount? 2,000 what? 500. All right. Oh, if I cannot write. 2,500 is my initial amount. Now my interest rate's 8%. It doesn't say, so it must be per what? Per year. And my N is what? 5 what? Years, but I've got to fix these two things because I can't have them. I've got to have them per what? Month. Okay. How am I going to change 8% per year to something per month? What am I going to have to do with that 0.08? Divide it by 12. All right, so if I take 0.08 and I divide it by 12, don't you get 0.00 and a bunch of sixes? Everybody with me like we did last time? So take it 4, 5, 6 places out. Everybody okay with that? All right. 5 years, but I need it not in years, I need it in what? In months. So what am I going to do with this 5 years? I'm going to have to do what now? Multiply by 12. So how many times are we going to calculate the interest on this thing? 60 times. So 60 months. So when I'm doing simple interest, as long as they match, doesn't matter what they are. But when I'm doing compound interest, they have to match and be the thing that follows compounded. Is everybody with me? So if it says compounded quarterly, I've got to have everything in terms of quarters. If it says compounded semi-annually or biannually, I've got to have it every 6 months. Is everybody with me? So I would sit here and put in my 2,500 right here. That would be my 0.00667 or whatever, and that right there is going to, that power is going to be my what? My 60. Is everybody okay? Now your homework's probably going to be a worksheet on Moodle. They'll be up this afternoon. All right. What we're going to do on Wednesday is we're going to learn how to do payments, like if you buy houses or cars. How do you figure out how much that monthly payment is? Okay. If you need me, come see me.